Sir, so this morning I have three problems about Gay Lussac's law. So in Gay Lussac's law, if the temperature increase, then the pressure also increase. That is the example of Gay Lussac's law. But remember that Gay Lussac's law, our volume is constant. Volume is always constant. So now, in problem number 1, the pressure of a gas is in a rigid container is to 125 kPa at 300 Kelvin. What will be the pressure of the temperature increases to 900 Kelvin? So now, before that, if we directly answer this question, so we can answer by multiplying into 3. So 300 times, the answer is this one, 373 kPa. But we need to follow the equation step by step. So what we are going to do here first is to find the T1, temperature 1, 300 Kelvin. Here 300 Kelvin, and then our temperature pressure 1 is 125 kPa. This is the absolute because kPa, we use kPa. So in temperature 2 is 900 Kelvin. So here 900 Kelvin, but in pressure 2 is unknown. So that's we are going to find the value of this pressure number 2. So now we use this equation, P1 over T1, P2 over T2. So now, but before that, we are going to write down here the value of our T1. So in T1 we have 112,500 kPa. So now over our T2 is our T1 is 300 Kelvin. So our P2 is 300 Kelvin. Then 300 Kelvin, we are going to cancel this one, cancel. Then we are going to divide. So 112,500 kPa divided by 300 Kelvin. So our answer is 375 kPa. So this one is unknown, so we write down here, and then this one is divide in 112,500 kPa. We are going to divide into 300. So this is the result. We try. 112,000 divided by 300. So that's correct. So 775 kPa, because we're going to divide this one in denominator, because remember that in 1 kPa is equals to 1000 Pascal. So that is the answer in problem number 1. So in problem number 2, the tire pressure of a car is 29 psi at 25 Celsius. So what will be the new tire pressure when the temperature of tires increases to 45 Celsius while driving on a road? So now we are going to find the value of our pressure 1, 229 29 psi. 29 psi, then the value of our T1 is 25 degrees Celsius. So in our pressure 2 is unknown. Then our T2 is 42 degrees Celsius. But before that, we are going to make it into the constant, into the absolute Kelvin. So from temperature, we are going to convert into Kelvin. So what we are going to do here is we are going to add the absolute Kelvin 273. Try 42 plus 273. So the answer is 315 Kelvin. So this one is 315 Kelvin because we are going to add 273 Kelvin. That is the absolute value of Kelvin into Celsius. So now, and also this one, the temperature, we are going to same as here. So we are going to plus 273 to become a Kelvin. So now we are going to use this equation, P1 over T1, P2 over T2. So our P1 is 229 psi. Then our T1 is 298 Kelvin. So we write copy here the P2 because this one is unknown. Then our T2 is 315 Kelvin. So now that we are going to cross multiply. So now 29 psi times 315 is the answer is 9,135. And then we are going to divide into 298 Kelvin. So we are going to write down here the 9135 and 298 divide is the answer is our pressure is 330.65 psi. But this is not the final answer because the question is asking this is yes, this is the final answer. This is the final answer. So our pressure in the problem is is increasing from 29 psi to 30.6 psi, meaning to say the pressure is increasing. So in problem number 3 in Gay Lussac's law, the pressure of the gas decreases from 820 mmHg at 80 Celsius to a pressure of 95 kPa. What is the new temperature in this Celsius? Meaning to say T2 is our unknown because this is the second temperature. So now we are going to find the value of our P1, 820 mmHg. So the T1 is 80 degrees Celsius. Then our P2 is 95 kPa. So this one is a constant because our absolute. So because kPa. Then now we are going to convert it into kPa. So first, pressure number 1 we are going to convert. So in 760 mmHg is equivalent to 101.3 kPa. So we're going to convert this one. Then 820 times 101.3 divided by 760, the answer is 109.3 kPa. So that's why we rewrite here the 109.3 kPa. So meaning to say, from mmHg to convert to kPa, this is the answer. This is the answer in kPa. And then the next is our Celsius to Kelvin. So what we are going to do here is we are going to add to become a Kelvin from Celsius. So the answer is 353 in our temperature 1. So now what we are going to do here, first we use this equation, P1 over T1, P2 over T2. So our P1 is 109.3 kPa, our T1 is 353 Kelvin, then our P2 is 95 Kelvin, kPa, kilopascal. Then our T2 is unknown. So now we are going to divide by both sides. So we are going to divide both sides. This one 909.3. Then cancel. Then we write down here this one, temperature 1. Then 33,535 divided by 109.3. Let's try. So 300,535 divided by 109.3. So correct. The answer is 306.8 Kelvin. So in question, in the problem is from Kelvin to Celsius. So our temperature decrease 353 Kelvin down to 306.8 Kelvin. So meaning to say our temperature is decreasing. But however, we are going to convert the Kelvin to Celsius. So we need to subtract 8. So the answer is 33.8, because our 306, then to become a Celsius, so we are going to convert it. So that's why our answer is 33.8 Kelvin Celsius. So that's all, sir.